Welcome everyone. This is Brian Autumn, and tonight I'm going to take you on a tour of the universe using my remote control telescope that's located out there in the desert of New Mexico, even though I'm here in the basement in Michigan. We'll be trying to handle your chat questions, so I want you to go ahead and type them in, and then I'll try to get to them at breaks. There'll be some natural breaks along the way, a lot of them, and I'll take requests. You can heckle me if you want. Please just don't use swear words. And so we're going to have some fun tonight. It'll be a lot like last night if you tuned in, although I certainly don't mind veering off course if people have a lot of requests. The wind is high in the desert tonight, and it looked like we are going to get blown around a bit, but I think we can carry on. So we're going to be seeing some pictures and videos of things that I've done. We're going to start close to the Earth, and then we're going to go way out into space for the tour of the universe. So we're going to be having some fun here, but we want to try to make it as interactive as possible. Now, I've been a fanatic watcher of the skies ever since I saw a blood-red lunar eclipse way back when I was 12 years old. And if you look out tonight, the moon looks like it's in an eclipse right now, if you peek out right now, because of the smoke in the clouds. But like a lot of amateur astronomers, I started with a little telescope, and I got a bigger one, and a bigger one, and a bigger one, until I couldn't, my back couldn't handle it. I love seeing outer space, but I love taking pictures, and so just started putting a camera on a tripod and taking things that are close by, like these pictures right here. Total solar eclipses are spectacular, but they're very rare. Unfortunately, dark backyard skies are also becoming very rare. Outdoor lighting is taking away our night sky. Most people listening to this can't even see the Milky Way from their backyards. And so this problem is getting worse and worse, this light pollution. So I had to take action. So I moved my telescope and camera from my backyard here in Michigan all the way across the country to a place called Dark Sky, New Mexico. It's down in the desert southwest. It's close to the Arizona border and not far from Mexico. And there's no light pollution at all, and when you look up, you feel like you're falling into outer space. Well, let's take a tour of this telescope ranch. All the observatories have roofs that roll off on wheels, kind of like your garage door. And if you on the left there, you see the big white building. That's my building. I have two partners with two additional telescopes with me. Other observatories there, you can see, have 1 or 2 up to 9 telescopes inside. It's clear there over 300 nights a year, much different than Michigan, and there's 4,000 feet of elevation under you, so you're up in a much thinner and a drier atmosphere. Much better for taking pictures. And can you see that blue deck up there ahead with the big red steel telescope? That was Clyde Tombaugh's personal telescope. That was the guy who discovered Pluto. Very cool. So earlier tonight I opened the roof up to let the heat out, because it's in the desert and it was hot today in the desert. It was in the mid-90s. It's above average out there. There's a bit of smoke, and it's important to open that roof up so it can let that heat out. We've got to let the heat out because it's hot inside, and cameras don't like heat. Hot camera is a very sad camera, so you don't want to do that. So I wanted to tell you that. So I'm going to switch over to now the live shot of the telescope control. Now we want to get over to the there you go. All right, now you can see me in the bottom right hand corner. In the top right hand corner you can see the telescope itself. And what I think I'm going to do here is I'm going to make it a little bit easier for you to see that telescope. What I'll do is turn on the night shot. The night vision. Basically, the night vision is it's the infrared, right? Infrared camera. So we're turning that on, and in just a second you'll see the telescope get lit up by the. There you go. So now you can see that the telescope is there. This is a live shot. By the way, you're on 10-second delay. That's just a normal YouTube streaming thing, so 10 seconds delayed. But the telescope is on a white mount. That white mount is the most critical component that I own. That's a robotic mount, It responds to my commands, and it tracks things across the sky. It was made here in Michigan. It's a Planewave L350, and it's been fantastic. We got a question here from Gretchen. All of this was done remotely from Michigan, even opening the roof. Yes. In fact, what's really cool is if I find myself away from my computer here in the basement, I use my cell phone and I can do everything. Take pictures, open the roof, shut things down. Yeah, it's amazing. We are in the golden age of remote observatories now because it's the technology doesn't require a PhD in computer science. If you look closely at the telescope, it's the black tube, and it's a regular old reflector. It's got a mirror at the bottom, and it's a 10-inch mirror, and it was born in Taiwan in the 90s, and it's a reflector 10-inch f5. And the weird thing at the top, do you see that box? It looks like a shoe box that's shiny. That is an insulated cooler box around the Canon camera. So, like I said before, cameras don't like heat. Desert equals heat. Bad combination. You got to take that heat away. And so I turned the cooler on at 3 o'clock today just to get things cooled down. And it looks like it's working pretty well there. And you'll see a plastic frame around the telescope. That's just a windbreak to try to break some of the wind. It really helps. We can get out there and do imaging even if it's if there's a lot of wind. And tonight there's a lot of wind, so we're going to hopefully be able to carry on. What you see here is my picture that I took just before we started. I was taking a picture of a star just to check focus. And so this is what we'll be using to see the picture. This is the camera control software. It's called Backyard EOS. Somebody asked last night about that. It's a wonderful product, been around for 9 years. It controls Canon cameras, and he's got a program that controls Nikon. It's fantastic. You can just set it up and it'll just go all night. Love it. It's great customer support. It's about $40. Now I'll be clicking over to the planetarium program. This is the whole night sky. If you take a look at it, the green circle is what we're pointing at right now. As you can see, we're pointing straight up, right? We're pointing at a star that is straight up. And so when I click on something, the telescope will move toward it. And we have a bit of a delay with the camera, but you'll see that the telescope will move just a few seconds right after I click, and you'll notice it moves very quickly. All right, so what time is it? It is time to try to chase a satellite. Watch the telescope. Watch it move. Now, we are tracking a satellite live right now. This is a Russian satellite in polar orbit, and this satellite was put up there in '99. You can see stars whip by in high speed here as we take a look at this. See the stars whipping by? I'm going to zoom in. And this is an Okean, O-K-E-A-N satellite, and it is basically a telescope in space, and it was set up there in '99 by the Russians to take pictures of the ground, to study foliage and soil and temperature and humidity, and it's basically a Earth observation observatory. We have to believe them and take them at their word for what it was supposed to be up there for, but it failed after less than 1 year. So what we might call this is a piece of space junk. Very expensive, multi-million-dollar piece of space junk. It only worked for 1 year from '99 to 2000, and since 2000 it's just been a dead piece of space junk up there. It's about as big as a bus. No, not as big as a bus. It's as big as a Cadillac Escalade, a big SUV. It's about that big. And it's basically a telescope, and it's got a bunch of cameras in it. It costs several $1,000,000, and so we're following it as it's whipping by space. It's kind of cool to watch this. I'll zoom out a little bit, and just it's amazing to see these stars whipping by, because we are going across the sky, all the way across the sky in 2.5 minutes. So this is a satellite moving across the sky. It's called OKEAN-O, Okeen satellite, launched in 1999 from Russia. And that was that still the Soviet Union back then? I'm not sure. It was right about the time of the breakup, wasn't it? Or it was after the breakup. Anyhow, it was still Russia, and it was also put up with the help from the Ukrainians. So this is something that is close by. In our tour of the universe tonight, we want to start with something that is close, and this is the close thing, because, and now we're super zoomed in on it. The light left this satellite just a millisecond ago, because we're only a couple hundred miles away. So light left there and hit us very quickly. That makes it the closest object in our show tonight. Another thing I want to show you here is, and I'm gonna go over here and stop it, because we've seen it enough here. I'm going to hit stop because we've seen it. And we've got another question here, and the question is
software with plane wave.
The software. We'll point to the question. Oh, FC Stargazer asks, is the planetarium software part of the plane wave mount? Great question. Absolutely. It's called, what you're looking at right here is called the Plane Wave Interface 4.0.5. So that's this program, and those of you might have seen Adrian's talk earlier tonight on Stellarium. Well, that's a beautiful software program that really mimics the night sky. As you can see here, this is more utilitarian. It's more fancy. It's not pretty, but it gets the job done, because basically all you're using it for is to click on something and then have the telescope go to it. So we're ready for our next stop in our tour of the universe. We started with something close, right by Earth. Well, what else is out there as we leave Earth? The moon. As I mentioned earlier, it looks like it's in an eclipse right now here in Michigan, because it looks very brown as I look outside. So now we are going to take a look at the moon. And we are zoomed in here. We better zoom out. Let's zoom out here. Boom. There we go. All right. So that is the moon. You can see the field of view of my camera will fit in the full moon almost perfectly. But there's some great features that we're going to see here. We're going to zoom in on first Plato. Right down here at the bottom is Plato, and look at that, is a very flat bottom crater. It's about 75 miles in diameter, and it is a flat bottom because lava filled that crater up. It used to have a very rough crater, probably with a central peak in the middle, but over the billions of years it's been filled in, and there's a little bit of a scar moving left and right there over here, and that is a kind of like a canyon. It's called the Alpine Valley. And you can see, though, we're boiling up. We got two things going on here. First, the heat is rising from the desert and going into space. It's causing a lot of turbulence. That's what happens in the summer evenings. We've got another problem, though, is we got wind. So we got two things going on that are kind of screwing up the view for us. Let's take a look at some of the other craters here. I think this is one of the better ones, right there. I'm not even going to guess which that is. It could be Aristarchus, but what's great about this crater is you can see the spray lines, the lines, the rays of when the space rock hit it. It just blasted things in a spray pattern, and we got some nice mountain range right there, curvy mountain range. I just heard today in a talk that the tallest mountain on the moon is 18,000 feet, which is on the order of the same as the taller mountains out here on Earth. And if we kind of take a look back at the whole moon, it's interesting to note that that we have these dark areas, which are seas. That's where lava has flowed. Let's go ahead and take a picture of the moon. In the software here, there's two things that control how bright the picture is. Duration is how long is the exposure, and ISO is the sensitivity that I give it. So for tonight, maybe I'll leave my sensitivity on 3200, but the moon is bright. So I bet you that if we get like 100th of a second or something like that, or 200th of a second, should be enough to get a nice picture of the moon. And it should be nice and sharp. Better than that video. That's why I'm taking a picture like this. Look at that. Way too much. Looks like we gotta go to a 3200th of a second. And this is just like a camera would behave taking pictures of the Earth. You're just playing with the exposure. All right, that's pretty good. I bet you I can do better with just a little bit more, 6400. And this camera is modified to be a little more sensitive to the red because a lot of the great things in the sky are red, as we will see. Definitely you can see a lot of these white lines where things recently where there have been impacts. The spray pattern is this white spray of lines. And one thing I want to show you is that we have these dark areas, which are the lunar Maria or seas, and that's the Sea of Tranquility right there, and Apollo 11 what happened right there. Now the backside of the moon does not have seas, and that was a topic of today's talk, and there's a picture of the front versus the back. The front is on the left. We see this. This is the face we always see. There is the backside of the moon that we never see, and look, there's only this one little sea, one little lava flow. And the reason for that is that the crust is thinner facing us, and the crust is thicker facing away, and also gravity helps pull the lava from the inside of the moon out to the surface, and it flowed. So there's your lesson on lunar geology. And the moon is far enough away that that light took a full second to get here. 1 second. So a light second away. So in our tour of the universe, we have moved from something close to Earth to something a little further, but still pretty close. We got another question here from Ken. The camera isn't sensitive to red, so we normally have kind of a pinkish cast, but it's even more brownish than normal because of, yes, the smoke has really caused us an issue. I'm going to turn off the infrared on the I don't want to have the night vision affect our pictures, so I'm turning that off. So the telescope's going to be a little bit harder for you to see, but if you look carefully, you'll be able to see it because the moonlight is very strong tonight out there, and so you can still see that it's there. So all right, so now we're going to go further out into space, our tour of the universe. We're going to go to something that light took 40 minutes to get here, and it's the planet Jupiter. Let's take a live view, a live look, video look of Jupiter. And I go 5x, 10x, and look at that. We've got Jupiter and these 3 stars next to it. Those aren't stars. Those are 3 of its moons. And I didn't look it up. It's probably Callisto, Ganymede, and Europa. Io is always real close to Jupiter, and it's probably in front or behind right now. And if you've got the Sky Safari software, the app called Sky Safari, which is the best one to have on your phone, all you have to do is zoom in on Jupiter and it'll show you where all the moons are. So I highly recommend that. It's a couple bucks, few bucks. It's the best there is, but there are many different apps you can get. So Jupiter is beautiful. It is boiling, you can see, because of the heat rising, but it's a pretty good view out there. We're lucky the wind has died down. It's better than it was when I first opened up today. Now let's take a short exposure of Jupiter because I want to show you those cloud bands. Jupiter has these amazing cloud bands that are in a horizontal line because Jupiter rotates so fast that it rips the storm clouds into horizontal lines. Equivalently for us, it's like it's like the Earth rotating 100 times faster than it really does, because Jupiter is much bigger than us. Maybe this far right dot is one of its moons. Yeah, that could be the furthest out moon. So there's 4 moons that are bright on Jupiter. The 4 Galilean moons is what they call it. But we have an exposure that's just still way too long to see the cloud bands. So I'm gonna zoom in here, and we're gonna get this next picture. There, now you can start to see the horizontal lines there, but they still aren't great. So we'll take one more shot at it. It makes it dim, but it does show. And maybe some of the other telescope viewers, I don't know if they've been able to do so much viewing here in Michigan tonight, the other live streamers, but some other telescopes are usually better off. This telescope I have is not set up for planetary photography. It's set up for far away photography. But you can start to see some horizontal lines there. And so that's Jupiter. And also, interestingly, in Jupiter, it rotates so fast that it bulges at the waist, like a lot of us. And so Jupiter rotates in 9 hours, despite being hundreds and hundreds of times bigger than the Earth. So it rotates so fast, and it's gas, so it bulges at the waist. So that was Jupiter. I'll get ready for the next picture. And like I said, 40 minutes for light to get there. What about Saturn, right next door? 80 minutes for the light to get from Saturn. Saturn is about twice as far away. Let's take a picture of Saturn. And this is always the object that overjoys people when they look through a telescope. They say, "I can't believe it! I can see the rings." It's just it's amazing. It's a beautiful object, and you can see the rings, and it's even better than this view through a live telescope. This right here is one of its moons. Its brightest moon. It's called Titan, and Titan is the largest moon in the whole solar system. It's bigger than our moon. It's nearly the size of Earth, and they think it has a frozen ocean, and they want to send a probe out there to poke a hole through it and sample. There could be life there, and they've also talked about other, I think it was Enceladus, another moon of Saturn that might also have life. So it's pretty exciting. I want to now see if we can take a picture of all the moons. Saturn has hundreds of moons. And so if we do a long exposure, we're going to blow out Saturn, but we're going to see probably a lot of other dots around here. Many of these dots here are Saturn's moons. If we zoom out, we might have more. Now, there might be a star or two, but a lot of these are Saturn's moons. And we can only see them if we take a long exposure. So we've gone 80 minutes away, and we're still within our solar system. I wish I could show you a comet, but there's no bright comets that we could see, so there's not a lot of other fascinating stuff in our solar system. So the next thing we'll do is maybe we'll check our focus. We'll go to our nearby star. What's a nearby star? Well, Vega, or pronounced Vega. It's 25 light years away. So we've jumped to one of the nearest stars, 25 light years away. It took 25 years for the light from Vega to reach us, and that's a close one. So this was also the star that was in the movie Contact with Jodie Foster. So let's take a 1-second exposure, and while this is happening, I'm going to explain to you how we can measure wind. Can you see right here? This has been turning colors. This right here has been turning green, yellow, and occasionally red. It's the tracking of the robotic mount. It's struggling to stay on the star, and when it turns yellow, it's telling us, "Ooh, I'm having trouble. The wind is blowing me off course. I'm working to get back." And here's the tracking graph. Okay, that's a bit of a mess. um, because the wind is gusting out there up to 8 miles an hour. So it's doing its darndest to keep us having good pictures, and it's working amazingly well. The amazing thing about this mount is it contains no gears, no belts. It's direct drive, meaning the motor is directly bolted to the shaft, and the motor directly turns it. But you can see we're having some wind out there, so we're doing pretty well considering the gusty wind that's out there. So that's the tracking, and then so this is our little anemometer right here. We can tell, and so if it's a lot of yellow, our pictures are going to be pretty marginal. But we're getting it. Now this is a close-up picture of Vega. It's 25 light years away, and if we take a look at the sharpness of the spikes, these spikes are created by the telescope. I have a reflector telescope, and it's got these 4 holders of the second mirror, and they create these spikes. If you have a refractor with a lens telescope, there's no spikes. Now some people like spikes, some people don't like spikes. I've seen people who use a refractor, a lens telescope, to take a picture of, let's say, an object in the sky, a nebula. They'll use software to create spikes, which just sounds hilarious to me, but it's true. And because the spikes are kind of aesthetically pleasing if you don't have too many of them. But anyhow, I don't think we're going to be able to improve the focus. I'll try one tweak. The focuser is motorized, and I have it all set up here. So what I'm going to do is I'm just going to go 2 steps inward. We'll take another picture, and then you tell me if it's getting better or worse. And this is the way I focus, but I have an automatic routine as well. Well, that's better. Look at this. That's the old one right there. Here's the new one. That's much better. Okay, so I'll set this to compensate for the temperature, because as the telescope gets cooler and the night falls in the desert and the heat rises and the temperature is dropping from the 80s into the 70s into the 60s, it's probably going to get down into the 50s tonight, the telescope tube shrinks. And as the telescope tube shrinks, the focus moves further out. And so you have to change the focus throughout the night as the telescope cools. Well, I don't want to stay up all night and do that. Well, this program will automatically adjust. Right here I've set it up for 3 steps per degree of centigrade. So if it drops 1 degree C, it'll adjust the focus 3 steps out. I've learned this over time, that's a good way to do that. So typically what I'll do is I'll set up to take a picture and I'll let it go all night, and usually it does pretty well there. Although sometimes the wind will come up at 2 o'clock in the morning, it'll close the roof automatically, and I got nothing. But that's what happens. So now we've fixed our focus, but we've also seen an object that's 25 light years away. All right, let's go a little further out, quite a bit further out. Let's go 4,000 light years out. And now we want to go to a place where stars are being born right now. So this is a place where stars are being born right now. It's called the Lagoon Nebula. And we click, and the telescope quickly moves to that. And this is where stars are being born. It's a glowing cloud, big cloud of gas. And so now we need to increase our exposure time. Let's say if we did... well, the moon is very bright, and the moon is hurting us, and so I'm not sure how much exposure to do. We'll just leave it like this. Let's do 30 seconds just like this. And so this is a long exposure, and we're collecting light, and because this is an object that is 4,000 light years away. And be sure to ask questions, because I am taking a look for if anybody has any interesting questions. You can ask anything you want. The Lagoon Nebula is in Sagittarius. Let's go over there and take a look at it. The teapot, see the little teapot there? I can zoom in a little bit. Yeah, there's the teapot, and coming out of the teapot is, and these green circles are cool objects. They are these they can be star clusters, they can be galaxies or nebulas, but all the cool stuff is in green there. All right, let's go full screen on this thing. Well, the full moon has made it kind of hard for us, so I'm going to zoom out right here, and there's a histogram that I can play with here. Let's just see what I can do here. What I'm trying to do is emphasize. I'm trying to subtract the moonlight. Okay, I'm trying to subtract that nasty moonlight there. Now yeah, I've done a pretty good job there. So this is a vast cloud of excited hydrogen. Excited hydrogen is red. It's the most abundant element in the universe, and it's what stars are made of. And these clouds will coalesce and compact, and gravity pull them together and get more and more tight and start to rotate and get tight enough so the fires of fusion will turn on, and the spark turns them on, and you have a star that is born. So that's how stars are born. They're born inside here. This little cloud of cluster of stars right here are brand new ones born out of this gas. And this is always funny. I have an update. It says that I have a Windows update that I could do right now. Do you think it's a good time for me to do a Windows update? I think not. And there's never a good time to do a Windows update. But it's a beautiful cluster here, and also this. There's a dark lane right here in the lagoon, and this is a cloud of dust. Smoke, like we have in the sky right now. This is smoke, and so the smoke keeps you from seeing what's behind. But it's this is my favorite type of object to take pictures of is these nebula. In fact, I had a license plate. Nebula was my license plate for about 10 years. So and you can see a lot of dark objects, and some of these dark objects are where stars are being born. These dark patches. Some people call them stellar cocoons, little dark pockets where stars are being born. So this is the Lagoon Nebula, and it's down there in Sagittarius. It's where stars are born, and it's 4,000 light years away. Let's look at another one of these stellar birthplaces. I can zoom in, and this one appeared on the bridge of the Star Trek in season 1. Back in the 60s, right above Captain Kirk's head. They changed it after, I think, the first season. It was just for a brief time. They had pictures of various astronomical objects on the bridge, if you go back and look at those old episodes. There's another one of those patches of, right there, a little protostar. They see that dark globule? It's called a Bok globule after an astronomer named Bok, B-O-K. I think those are Bok globules. So, but you know, this is just a 30-second exposure, and we're seeing a lot of detail, and that's what's so fun with this. When you have dark skies, relatively fast telescope, and a good camera, you can get a 30-second shot. This is called the Trifid Nebula because it's got three lanes. These are dust lanes. Okay, that's smoke. Smoke keeps us from seeing what's behind. Red means where stars are born. These stars here were just born recently. Right there you can kind of see a finger, and a star is being born probably at the tip of that finger right now. That's another one of those stellar nurseries. But it's interesting is that this one has a little blue nebula. See the blue nebula right next to it? Fascinating. The red nebula is hydrogen gas that's excited, and it's glowing red. The blue is not glowing at all by itself. It gives off no light by itself. It only reflects probably the light of that star right there. So it's a cloud that reflects, but it does not have any light by itself. That's called a reflection nebula. So there's various types. This picture has 3 types of nebula in it right there. You got emission, or the glowing. You got dark nebula, and then you have reflection. So those the 3 there for the Trifid. And the Trifid is about, let's see, 5,000 light years away. So Gretchen says, It's interesting that you cannot switch out the lenses and cameras. Is there a contact you use in New Mexico to make physical changes to your scope? Absolutely, great question. Yes, having on-site support is critical. These telescope ranches, these hosting places where you spend a monthly fee and they take care of your telescope, is an exploding phenomena. It's happening all over the world right now because of technology and light pollution and people getting into astrophotography. So it's popping up everywhere. But it's important to have on-site help. And at my place, I have people who are there all the time. So if I have an emergency, like if the roof won't close and there's a storm coming, there is somebody who can get that roof closed. If I accidentally run the telescope into the ground or do something stupid to it, there's somebody who can unplug and replug, although I have capability to do that remotely. But the things that I usually need help with are pretty simple. Rebooting the surveillance camera, changing the position of my surveillance camera. But twice a year I need to be out there usually and to do maintenance. The telescope needs a good dusting right now. It's pretty nasty. It's got dust all over the outside the tube. The mirror is pretty good. I usually go out there in November and March to do maintenance. But it's amazing that I've had this for 6.5 years now, and it has worked very well, and I haven't had any real mishaps. Lightning did strike the building and blew out the hard drive, or I'm sorry, the motherboard of the computer, which was pretty amazing. And because I had Dell on-site support, the tech drove 200 miles to come and put a new motherboard in. And so I was very happy with that. The amazing thing about that Windows 7 machine, which you're looking at right here, it was made in 2013. It has been running 24/7, 365 for 7 years in a dusty, hot environment because it gets in the 80s in the control room in the summer. That's amazing. 24/7, 365 times 7 years. So I'm very happy with it. Yes, it's about to go poof right now. It'll probably die as we're talking. But one of the things I need to do is, because right next to this is sitting a brand new Windows 10 machine that I need to switch to, because I want to get more automated software. I want to do software so the telescope will actually go from object to object to object and operate by itself throughout the night, so I can sleep more. Right now, I can set it up to do one object, then go to bed, and it does that one thing quite well. But it's done by 2 or 3 a.m. If I get the Windows 10 machine up and some good automation software, I'll get it to go at 2 a.m. to another object, focus again, and maybe to another one at 4, and so on. But on-site support is critical. We have good on-site support there, but there are many things that you can only do by yourself. And given the plague, I don't know if I'll be getting out there in November. So we've seen 2 places where stars are being born. They're about 5,000 light years away. The next one is the Swan. It's also M17. M stands for Messier. He's the French astronomer who cataloged a lot of the great objects in the sky. They were great, not really to him, because they were just fuzzy blobs that he wanted to catalog, because they were false alarms when he's looking for a comet. Because he was looking for comets and he was rewarded for finding comets. So his job was to find comets, and so he saw these fuzzy patches in his crappy telescope, and he would mistake them for comets, and then he started to catalog them so he wouldn't be mistaken. So, but nowadays they're known as the greatest 100 in the sky. Interesting, you can see here the very different star colors. Look at that yellow star right there and a very white star there. Oh, is this a suggestion somebody had?
I think so.
Yes, Paul has suggested the Crab Nebula, and that is a supernova remnant, and we will see if we can see that, but I'm not sure. All right, this is the Swan, and doesn't it look like a swan? There's the body, tail out the back, and then curvy head right there, curvy head. So that's the Swan. Some people call it the check mark. Looks like a check mark. Some people call it an omega. Looks like an omega. But what's good about this shot is you can see not only the swan, but all this other gas that surrounds it. It's a pretty big object. If we go full screen on it, you'll see that there's gas that goes quite a bit, pretty far around. Okay, and this is a yellow star down here, but this is a very, very beautiful. If you have a telescope, you got to see this. And when you have a telescope, what's way cool is you can see this chunkiness. See how it's very mottled, chunky, curdled? You can see that in the telescope. Very cool. And if you have an oxygen 3 filter, it makes it even better. Highly recommend that. So, and this is an object that is in the summer and the fall. But this is the summer Milky Way is still around, even though we are in September. But shortly it'll be gone. So it's time to get out there and see some of these things. So we've gone on our tour of the solar system. We're about 5,000 light years out, but we've looked at 3 things that show where stars are being born. 3 red things because they're excited hydrogen gas. So once a star is born, let's try to take a look at a star that has been born. Not only one star, but a bunch of stars. What happens when a bunch of stars are born together out of that red cloud? What does it look like? Well, this is called the wild duck cluster because an astronomer in the 1800s in his small telescope thought he saw a V formation of ducks flying through space. And you can be the judge as to how well this resembles what he says it's supposed to be. I see that our wind gauge was yellow for it's almost red for a time here, so I think we're going to see some blobby stars as the robotic mount struggles to keep us pointed straight. It's doing a Herculean effort, but it really has trouble when we have wind gusts up to 10 miles an hour. All right, that's not bad. Now, if I look carefully, I think the V goes like this. But anyhow, this is the wild duck cluster. It's a beautiful open cluster, and it's pretty concentrated. These several hundred stars were all born together. They live together, but then they slowly drift apart over time. And it's a very beautiful little star cluster right in the middle of the brightest part of the Milky Way in the summer sky, or the autumn sky. So that's called the wild duck cluster. Now that we go back, we had a request for the Crab Nebula, and the Crab Nebula is not up. The Crab Nebula is more of a wintertime object. So this is the east side, and so the Crab Nebula is below east, below the horizon right now. So sorry, Paul, we're not going to be able to see the Crab Nebula tonight, but we will be able to see another supernova remnant, and we'll definitely look at that. So we saw one star cluster. Those ducks, those flying ducks there, they were 6,000 light years away. So we're all in the 5,000 light year range in the Milky Way. Well, now we're going to go out to 22,000 light years away to see the Hercules cluster. And you see Hercules there? He's got his arm pointed there, a leg, and a big club. He's going to whack something. I don't know what he's going to whack, but it looks like he's definitely getting ready to do something there. This chart does use unusual figures, doesn't it? I mean, look, the Big Dipper is not just that, but it's also this other structure. And then Hercules is an unusual. But Ophiuchus here does look like the serpent bearer. You see the leg, body, arms, and each arm is holding a snake. Snake there, snake there. So that's pretty good. This is the eagle. I wish we could superimpose the drawings of the constellations over the top of this. The program, The Sky, does that. And it's beautiful. Perhaps Stellarium will do that. You should take a look. So now we're going to look at the Hercules cluster. And Hercules is fantastic through a telescope. It is the most amazing view. It's pretty good to take a picture here. This is a pretty darn good picture with nearly a full moon and a 30-second exposure. And these stars are packed in. I believe there's 200,000 stars here, and they are packed in into a ball. You know, it just kind of reminds me of a popcorn ball, doesn't it? Looks like a popcorn ball. Anyhow, it's these were all born together, but what's interesting about these globular clusters is that they are in a weird position in our galaxy. I'm going to use this book as our galaxy. You know, our galaxy, the Milky Way is shaped like a frisbee, a round. This is a square book, but you can envision round. And most of everything is inside this book, but these globular clusters are above and below. Above and below, not inside. And so there's something different going on with the way they were formed and the way they live. So I'm not up on a lot of the theory as to why and how these were formed, but they're fascinating because there are a lot of stars all packed together. And I read once that it said that if we were orbiting one of those stars right in the middle there, if our planet lived in there, we would have trouble sleeping at night because it really would never get fully dark. Another thing that's fascinating about this cluster is, look at the void. There's a dark void right there. It looks like a black hole, right? The black line right there. It's kind of fascinating. And right here, you can see a blue star. No, that's not a blue star. That is a bad pixel in the camera. Okay? Bad pixel. And as the camera gets hotter, you get a lot more of these bad pixels. And there's another bad one right there. So when you really zoom in, you can see the effect of heat. And if you look right up here, you see that the camera is currently operating at 75 degrees. That's pretty good, because if I hadn't been cooling it, it would be 95 right now. So we've got to get that cooler on. But I don't see a lot of bad pixels. And the stars are a little bigger and blobbier than normal. That's because of the wind. Let's check the tracking. See, it's a little better now. The wind has calmed down. If it stays within the plus or minus 1, we're fine. That's the accuracy of my telescope and camera. But as it starts to explode above and go to the 2, the 3, the 4, that's when the stars get bloated. Okay? And usually the wind dies down as the evening goes on. So I think that'll probably be the case tonight. We have another question. David Rowe has, how about the Crescent Nebula? Yeah, I think the Crescent Nebula is a great idea. Okay. And then M92 is also great. So I'm going to go to M92. And David, why don't you chat the NGC for Crescent? Is it 6888? I think that's it. Anyhow, but as long as we're in the neighborhood, we can go to 92, which I believe is right there. There it is. Hit go to. And it is also right up by Hercules' club. And this is a very pretty globular cluster. There was a good article on globular cluster in last month's Sky and Telescope magazine. But these are beautiful. Each one is a little different. Some are packed in, some are more spread out. But I really urge people to take a look at this with a telescope, because it's easy to see and it's fun. And it's not like some of these nebula and certainly galaxies are harder to see with a small telescope, but these globular clusters are easy to see. All right, now you can see that immediately, if we switch back and forth, it's clearly smaller, or apparently, but it looks like it's even more packed in at the center. I mean, we've overexposed the middle. There's so much in the middle. We've totally overexposed right there. So that's M92. All right, the Crescent. Oh, there we go. I'm going. All right, the crescent is another one of those stellar birthplaces. It's another one of those red nebula. So we're going to hit start on this one. Go back. This is the Northern Cross, Cygnus, the swan. That's the cross this way and this way, or the head of the swan. The swan is flying upwards or northwards. And we're not showing the Milky Way in this, but the Milky Way goes right across here. I can actually show you a picture of this, or a line. Oh, we're going to put the galactic plane there. This is the Milky Way, the green line. So the Milky Way is perfectly overhead. So I wish I were out in the desert tonight because it would be spectacular. You could just lay down and look up and you see the entire Milky Way right all the way from this horizon to this horizon. So it's the perfect time for Milky Way. So at high power you can see here that we've got some curviness. It's called the crescent, right? All right, see the curve? That's the Crescent Nebula. And as you can see, it's kind of a faint one. It's a little bit harder to see than some of the others. Let's go 45 seconds. Another thing that we are doing here is, are we getting further away from the moon? Because that's a good thing. Yeah, the moon's down here. We're up here. The further we can get away from the moon, the better. Because as a astrophotographer, I hate the moon. I wish it weren't there, although it would probably kill us all if there was no moon. But I don't like the moon because it just messes me up. I really can't take good pictures because I have a color camera. If you had a narrow band camera that uses filters, and it's a black and white camera that uses filters, then you can take great pictures during the full moon. But I can't do that. So I pay the price for simplicity. I like the simplicity and the ease of color. I've always started and used color cameras, but you pay a price. So, and the price is during the full moon, you're going to really have trouble getting good pictures. But you can get pictures of star clusters because they're bright. So I do things like that. All right, now you're seeing it, aren't you? So we've cranked up the exposure. Now we see the full extent. But you're also seeing noise, don't you? So as we cranked up the exposure and the sensitivity, now you see some of this noise. And since we're operating at 75 degrees, camera doesn't like to be hot, we got some noise here. If we were to take this same picture at 40 degrees, we would see almost no noise. So that's a big difference. And so wintertime is a fantastic time. But this is so thank you, David, for the suggestion of the crescent. That's a beautiful, beautiful picture. There's the crescent, and you can see in this image here, you can see the moonlight is hitting the tube and causing this coloration. That's the moon. Oh, what's also beautiful is look at the two different stars there, but this very red star. Red or orange stars are usually bigger and older. They can be a supergiant. So that is 6888, and that was probably several thousand light years away. So what is on our journey across the universe, what's next? Well, we got to think about what happens when stars are dying. So let's take some pictures of dying stars. Now, different stars die in different ways. When you have a star like our sun, which is kind of average, they puff out their atmosphere over time and slowly form a bubble. And this bubble will get bigger and bigger and bigger, and then finally they will just puff out. The star will die, and that's the way our sun is going to die. But before that, that hot bubble will extinguish all life on Earth because it will be thousands of degrees, and it will burn off our atmosphere slowly and kill everything on Earth. But we've got several billion years to worry about that. The Ring Nebula here is one of the best things you can see in a small telescope. It is just fun. It looks like a little Cheerio. I've heard people say it looks like a Cheerio, looks like a sugar donut. You can't see color in a telescope with your eye because the eye is not sensitive to faint things that are colored. Like if you look at the garden at night, you're not going to see colors of your flowers in the garden at night. Same thing. You're just not going to see colors here. But this is the Ring Nebula. It's fascinating. It is a bubble, and you can see the central star, the one that's dying here. You see that right in the middle. Right there. And some beautiful blue coloration in the middle, and more red on the edges. So this is the Ring Nebula in Lyra, near Vega, and this is right here is a faint galaxy. This is, let's see how far away, 2,000 light years away. Well, this is a faint galaxy that's many times further away than that. But we'll get to galaxies at the end of our tour tonight. Let's take a picture of another one of these galaxies. There's a question about how I cool the camera. All right, I'm going to start the next picture and tell you how to cool the camera. The camera does not like to be hot, like I said. So it's a Canon camera. I didn't want to take it apart and put a cooler on it and destroy the integrity of the camera. So what I did was I made myself a cooler box. It's an insulated box. It's aluminized mylar bubble wrap. It's basically bubble wrap. It's aluminized bubble wrap and made it into a shoe box. It goes around the camera, and it's got a thermoelectric cooler on it. And it's a thermoelectric cooler. It's the same thing as you got if you want to get a cooler for your car that plugs into the cigarette lighter. It's that. There are these little devices that work off 12 volts that cool a vessel, like your cooler in your car. I just bought one of those and put it together with this box, and then put it all around the Canon camera, and that's how it cools it. It doesn't do a massive job, but it does do a pretty good job. I could get a bigger cooler, more insulation, but it's worked well. And this is the Dumbbell Nebula. As you can see, it is many times bigger than the Ring Nebula, so the gas bubble has expanded even more. And so one thing we see here is we're kind of overexposing stuff. So what I'm going to do here is I'm going to drop down. We're going to go back to 30-second exposures. But you can see it's shaped like a football, and it's expanding. It's one of those really fascinating and very colorful objects. Really fun to take a look at this through a telescope. It's easy to see, even with light pollution. All right. And last night we had a request, and it was pretty cool. It was the Saturn Nebula, I think it was 7007, I think it's called. Oh, I blew that. That's not that. It's not. All right. Oh, the cat's eye. The cat's eye was way cool last night. It's another one of these dying star nebulas. 6543, and it's in Draco. Here we go. And we're zooming up to Draco. Draco is like a snake. Can you see it there? Very snaky. Okay. And what is amazing about this is that all we need is a 3-second exposure to get a good picture of this cat's eye. And this is a dying star nebula. And each one of these is different. They're all very unique because they're these shells of bubbles of gas that are in various states of being expanded. All right, there's the cat's eye, and we've got too much exposure there. 1 second. Let's do 1 second exposure because you can kind of see, we'll be able to see kind of the iris or the structure within the cat's eye. As you can see, the wind is still kicking up out there. There, can you see some very fascinating little details there. That's the cat's eye. And it's kind of aquamarine, isn't it? Also last night, somebody recommended the blue snowball. And it's over in the constellation of Andromeda, which is right next to Pegasus. Take a picture of the blue snowball. So we got a lot of different colors with these dying star nebulas. They can be blue, they can be green, they can be red. Range of colors. And the ones what we've been looking at are things that they're a couple thousand light years away. So most everything we've been looking at is pretty close to our neighbors here in the Milky Way. Light took 2,000 years to get here. There's that blue snowball. And yeah, the Saturn. The Saturn. We're going to do Saturn. I'm going to do the Saturn nebula, and then I'll answer Chad's question. I was going for Saturn, and yeah, I didn't know the number. I couldn't read my own writing. Okay, 709. 009, right? There it is. Right? I thought it was its own dot. Let's go a 10-second exposure. It's easy to overexpose these planetary nebulas or these dying star nebulas because there's a lot of detail within them, and they're filamentary. Yeah, this is called the Saturn Nebula, and we're close to the moon. That's why we're getting all this darn yellow light. So it looks like it's got handles, right? Handles on the side. So that's the Saturn Nebula. Let's look at the chart here. Look where we're taking a picture. Moon there, pointing here. All right, that's a tough task. That's a very tough task to try to do this. What's this over here? The helix. Okay, this is the largest planetary nebula, or the largest dying star nebula, because it's one of the closer ones, and it's been dying for a long time. And so let's see what we can do. Now, even though we're close to the moon, if you are a follower of mine on Instagram, this is the picture that's my avatar. Some people call this the Eye of God, because it looks kind of like an eye, and it's big. So we got to zoom out. Zoom out. And this is almost a fail, isn't it? It's almost impossible to see, but it's right here. And I think that we are not going to get a decent picture of the Helix Nebula when we are so close to the bright moon. So we tried, but we failed on that one. Let's see if we can get stuff that's a little bit further away. Oh, we have a question about from Chad. What's the ID system for object names like NGC 6543? Yes, NGC stands for New General Catalog, and I think that was done over the 40s and 50s. And so yeah. Adrian, I'm going to need the NGC for the Bat Nebula, but I can imagine that it's going to be pretty darn hard to see it. But NGC is it's a cataloging system that astronomers used, I believe, in the middle part of the last century to catalog all the objects in the sky that weren't stars. And so I think there's up to 8,000 in the list. So it's new general catalog. So Messier, he did his 0 to 100 catalog back in the 1700s, but then in the 1900s we got 8,000 objects. And then there's other catalogs as well, IC and others, and in recent years there's catalogs for everything. So what's good is that the software can search and find all of them. But yeah, this was a fail. This very hard, very hard. And I don't know what this thing is on the right here. This reflection of something from the moon, if the moon's causing that. But there was a question from Ed: how do you take darks with a remote telescope? It's a great question. When you are, when I zoom in, we can find bad pixels. Okay, there's bad pixels, and though they don't move, they're in every picture, and so you need to get rid of them. And so what we do is we take flats and we do darks. I'm sorry, I'm going to talk about darks first. And so what you do is you put the cap on the telescope, you take an exposure, and it's called a dark frame, and it's going to have those bad pixels, and then you can just subtract that from your pictures and get rid of the bad pixels. It's a wonderful technique. And how do you do it with a remote telescope? Well, what I do is when I'm out there every 6 months, I'll take my darks. I'll take them at 45 degrees, 60 degrees, 70 degrees. So I have them at each temperature, and I'm lazy, so I just keep them and reuse them. The purists say, "Oh, that's stupid. You got to do them every day at the same time." Well, I don't. I find that I can get good results without doing all that effort. So that's called dark frames because they get rid of your bad pixels. The other very important type of calibration is flat frames. This shows you very dramatically that we have a problem with this optical system in this camera. But most everybody has the same problem. The corners are dark. It's called vignetting. And so the telescope is not really big enough to fill the frame all the way around. So the corners are kind of cut off. There's just not doing a good job of fully giving light to the corners. Well, if I take a picture of just the bare sky, or I have a very nice white light that I set over the telescope tube, and take just a uniformly white light and take a picture, it'll look in this same shape. And if I subtract that, then I don't have these corners. So that's called flat frame. So astrophotographers always talk about flats and darks, and those are very important. You can't get a great picture without flats and darks, but I find that I can use 1-year-old, 2-year-old flats and darks, and I'm just fine. Also, post-processing, you can play with the various programs, and they'll help you as well. If you don't have flats and darks, you can still deal with it after the fact. All right. So what is going to be next on our tour? We've seen some dying star nebulas. We've seen how stars that are medium-sized, how they die. Well, what about big stars? Huge stars, how do they die? Well, they blow up. They blow up spectacularly. They explode. They become supernovas. So right now, we're going to take a picture of a really cool supernova called the Veil Nebula. And this one is 1,500 light years away. And the explosion happened thousands and thousands of years ago. But the shrapnel, the shock wave, is still whipping across space thousands of years later. And this shock wave that you're going to see is moving at many dozens of miles per second, which is almost incomprehensible how fast this shock wave is going through. Someone earlier, Paul, asked about the Crab Nebula. It's the same type of thing. It's the leftovers from a huge supernova explosion. So we're taking a picture of a star that died in a spectacular fashion. And this is a nice picture because we are far away from the full moon. So we've got a nice picture of this shock wave. I'll zoom out because I want to show you that it's curved, right? and it's a shock wave. So it means that the explosion happened this way, in this direction. So the shock wave is moving like that. So it's beautiful. It's filamentary there. See the filaments? It's diaphanous. They call it the veil. Translucent. It's a beautiful object. Long exposure are just beautiful, and it's got many colors and striations. You can see it's bluish green right there and red. So it's a fascinating object, and it's where the higher elements have been born in a big star, and those elements are spread out through the cosmos in the explosion of supernovas. So we are star stuff. We have another question. FC Stargazers asks, does your telescope sleep on its side when you close the observatory since you can't close it? Well, I do close the roof, but you're right. The telescope, I can't cap it. I wish I could cap it. I could probably develop a cap system. There is a cap system that some people used for with the light to make those flat frames. So I just have a home position that's pretty horizontal, so the dust won't get inside and land on the mirror. So that's the bottom line. I store the telescope mostly in the horizontal fashion. Good question, though. It's a good question because, one thing about remote observatories that you set everything up in your backyard first. You get it working perfectly, and then you move it. I've seen so many people have problems, and they haven't really worked it all out. They've never assembled that technology, and then they assemble it for the first time out there 2,000 miles away from their house, and they come home and it doesn't work. It's because you got to get comfortable with it. It's got to work very reliably, because even though there are people there that help you, if it's just not working or repeatedly malfunctions, you're not going to have anybody helping you. So the technology can cause you to tear your hair out, but I've been fortunate with this plane wave from Michigan here. It's super reliable. The previous mount I had was not reliable, and I had real customer service problems. So when you have something that's gone wrong 1,000 miles away, the problem is magnified. So this Veil Nebula blew up thousands of years ago, but it's only 1,000 light years away. So I think it is time to make the big jump after we ask. Adrian asks, Brian, have you ever taken a Strubel's worth of integration on an object? I don't know what a Strubel is. I think he's making a joke. Integration is a fancy term for how long exposure. You saw some of my pictures, perhaps on the slideshow, which I can. Take hours and hours and hours of exposure, and you use the software to stack up all your images, and it gets better and better. And I don't know if you saw Gordon or some of the other folks demonstrate their telescopes tonight or last night, but they do live stacking. I'm taking one picture, right? I take it for 30 seconds, it comes up, we talk about it. But another technology is you just keep on taking 30-second exposures, and you add and add and add, and the software will add it up, and that's called integrating or live stacking, and that is a wonderful technology as well. And I'll probably have that for my next telescope and camera combination. So let's leave the solar system. Let's leave the Milky Way. Let's go off into a different galaxy. And who's our neighbor galaxy? The friendly Andromeda galaxy. You just saw the pictures that I showed you. And so let's take a 30-second shot of one of our closest neighbors. And we actually happen to be on a collision course, right? Aren't we going to slam into the Andromeda galaxy? So I think we are. And but we'll be dead, so it'll be all right. And it's not going to be for a billion years. But the cool thing about it is that there's not a lot of collisions, because imagine two swarms of bees going through each other. They don't hit. But what will happen with bees and stars is they'll come close to hitting each other, and they go woo when they get thrown off of their previous orbit. So that's going to happen a lot. It's going to tear apart our galaxy. So that's a nice shot of Andromeda. Let's go full screen on that. And we've got the full moon kind of causing a lot of white light here. But there you got the nucleus of Andromeda. Now look at this is 200 billion stars. Maybe 100 billion stars. These other stars you see in the picture are our close neighbors. These are stars that are between us and the Andromeda. These are in the Milky Way, everything you see here. But the fuzz, the glow, that's the far, far, far away Andromeda galaxy. It's 2.5 million light years away. And fascinatingly, you can see these dust lanes. And we can zoom in on some of these dust lanes. And just note, you can see that these are dark, smoky clouds that prevent us from seeing what's behind. But they surround the spiral galaxy in a ring around the waist of it. So that's Andromeda, and Andromeda has two friends, two companion galaxies there. And this one's called Messier 110. This is Messier 32. And Messier 32 is very compact. Those stars are just jammed in. And this is like a globular cluster on steroids. Remember, globular cluster was a ball of, what did we say, a couple 100,000? This is a ball of billions. So I've heard it said that this object right here is intrinsically super, super bright. So if it was closer to us, it would really, really be dramatically bright. But yeah, that's Andromeda, and it's one of the most amazing things you can see. It's the furthest thing you can see with the naked eye if you're out on a dark, dark night in northern Michigan or out in the desert. And if you know where to look, it looks like a misty little elliptical, like a football, little fuzzy, small football. So that's Andromeda. And we might be able to see another galaxy that's also about 2 or 3 million light years away, and that's the pinwheel. I almost said pinhead, but pinwheel. And this looks like a pinwheel, as you'll see. The galaxies are of various different shapes, and it usually has to do with how far along they are in their evolutionary process. When they're younger, they're more like a spiral or a pinwheel, and then they, if they've had interactions with other galaxies, and if they're older, they basically are jammed up fuzzball, like this one right here. But I think M33 is more of a nice spiral. Everybody likes spirals the best, especially if they're face on to us, or edge on. They're pretty cool too. Yeah, we got the moonlight doing weird things, but definitely you can see the spiral arms there, right? You can see several spiral arms, and there's a chunk of stars right there, a chunk of the galaxy right there. You can zoom in some. It's kind of purple. This chunk right here is purple, and this chunk of this galaxy was taken a picture of by Hubble, and the detail is spectacular. The Hubble resolved this into individual stars, and it's just amazing. And tons of gas. There are places here where stars are being formed at a ridiculously high rate, and this is one of them right here. So that's M33, and that's about, I think, 3 million light years away. And if we don't have any other requests, I'm going to try to do something that is usually impossible, but last night we were successful. We're going to try to take a picture of something that is 8 billion light years away. It's the furthest thing that I've ever taken a picture of, and 8 billion light years away means that it is more than halfway back to the beginning of time, which is 14 billion light years ago, where the Big Bang happened. So we turn this on. PGC 69457. There's more digits on this one. And we'll go to this. And we want to try to go as long of an exposure as we can without totally saturating the field of view. With the moon being so close, it's going to be tough. We'll leave it at 30. And this is a quasar. We're taking a picture of a quasar, and it's a quasi-stellar object. It's a very active galaxy, super active, but very, very, very far away. And the only reason we can see it is because it is behind a closer galaxy that has bent the light into a very freakish shape. And I'll show you the freakish shape here. Now we're not going to see this detail, but in the middle is the galaxy, PGC 69457. Way, way, way behind it is the super bright point source, which is called the quasar, 8 billion light years away. We can't see it directly, but this galaxy bends the light around it in 4 ways. It splits the light into 4 chunks and then bends it around, and so we see 4 points of light, but they all are from being bent from the center. So it's called Einstein's cross, and Einstein predicted these types of objects, and they were not observed until way after his death. So it's called gravitational lensing, or basically gravity bending light. So it's bent light into 4 pieces here, and so it's an amazingly 8 billion light years away. And I know from previous pictures that if you take this and see this line of stars here, it tells us where to point. And the object is right here. All right, we are at the limits of our ability right here, but this little fuzzball, this little patch right here, is that Einstein's cross. That picture you saw from, or the blue picture, that was from the Hubble. Okay, now even Hubble had trouble zooming in on it, so we are looking. All we can do is just see the entire object. We can't resolve it into those 4 dots, but just believe me when I say that that is 8 billion light years away. So that is the furthest thing that we're going to ever see, the furthest thing I've ever taken a picture of. My previous record was about 1 billion light years away. Okay, David Rowe suggests the fireworks galaxy. I think that's a good one, and I'll be excited if it's far away from the moon, which we're going to find out in a second. So it is new general catalog 6946, search. Oh, okay, good. It's up by Cepheus, which is the house. See the house right there? Right up there. Let's keep the exposure the same. So let's take a look at the house. Cepheus. There's the North Star. That's the Little Dipper. There's the Big Dipper right there. Here's the pointer stars, the bowl of the Dipper, If you take those and point and go up, you hit the North Star right here. Great Square of Pegasus right there. Andromeda comes off the Great Square and has that beautiful Andromeda galaxy, which is great in binoculars as well. Somebody hasn't asked for Mars yet. It's right there. It's not up far enough for us to see. I got a high roof on the east side. This is E for east there. So it's got to get up probably about this high in order for me to be able to get a picture. I don't think we're going to be able to see Mars tonight. But if you check in with me in the next 2 weeks, we'll get some Mars pictures. We'll get some good Mars video. But Ani and others will be broadcasting, I'm sure, over the next coming weeks. And Jeff, Orange Can, so they are more set up and do much better planetary photography than I do. Mine's set up for faint things. There's the fireworks galaxy. It's faint. Tough to see. I think this is the one where there's a vast dust bubble, or there's a vast dust cloud between us and them. And so if there wasn't a dust bubble between us and this galaxy, it would be the brightest galaxy in the sky, because it's relatively close to us. But it's just faint. It's kind of like tonight. When we try to go out there and look tonight, there's smoke and we can't see the sky very well. And it's the same thing. Well, since it is so far away from the moon, let's crank up the exposure. Let's do 60 seconds. And let's do ISO 10,000. Let's go crazy. Because this is it's a very attractive galaxy. It's a face-on, meaning you're seeing the spiral arms really, really well. So you can see my strategy on full moon nights. I try to avoid the moon. I try to take pictures well away from the moon, and I try to stick to objects that are brighter. And when there's no moon, well, that's when you can go off and go galaxy hunting. I also like to take pictures of asteroids that are flying by, and I make little movies. That's kind of fun. Comets are fantastic. It's just unusual to get them. We had some good ones over the last couple of years, but you can't predict them. They're really hard to predict. So Norb Vance says, what about Stephan's Quintet? Okay, that's our next shot. And we're testing the extreme exposure here, so let's see what 60 seconds at ISO 10,000 does. That is a lot of light. Too much. Now, up here we have the histogram. What happens if I try to fix it this way? It's not doing much, is it? Well, not a lot we can do. Oh, that's pretty good. That's pretty good. Yeah, what we're doing here is we're just trying to subtract the moonlight. Little more. All right. Anyhow, you can start to see some of the cool arms. See the spiral arms there? Yeah, it looks kind of like an insect, doesn't it? Like a spider or something. But they call it the fireworks, because it looks like fireworks. But it's very pretty, and I don't think I got the question, but I can tell you that when I take a picture of something like this, I'll take 5-minute exposures. Okay, I'll take 5-minute exposures, and I'll take a 5 and 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 a 5, and I'll do that for 4 hours. So that's how I do it. I don't take one picture for 4 hours, because you'll see that if you do that, you totally will overexpose the background sky. So if you take 5-minute exposures and they're all nice and sharp, then the software will add them together and you get a nice and sharp picture in the end. 7319 Stephan's Quintet was featured in It's a Wonderful Life with Jimmy Stewart. When Clarence was communicating, they used a picture of this galaxy, this set of galaxies, as to represent heaven, I think. I'm going to back off a bit. Let's go to 45 seconds. It's called Stephan's Quintet because it's a quintet of galaxies, all packed in together. It's a wonderful observing challenge with the naked eye in a telescope. Oh, unfortunately, we happen to be taking the picture during some nasty wind gust. Let's just, I'm going to see what kind of wind, what we're getting here. Well, a 12-mile-an-hour gust. We're getting a 12-mile-an-hour gust right now, so that's what's going on. So it's going to be, how bad is this picture really going to be? We're going to find out. What's good about, if I take these 5-minute exposures for 3 hours, hey, I can throw away a couple. That's what I do. And their software will automatically pick the ones to throw away. Yeah, so you can see that the quintet is very small. There's 2, 1, 2, 3, 4, and then 5 is probably that faint one in the middle. 1, 2, 3, 4, and I think 5. So again, if we didn't have the moon, we'd definitely see this much better. So I'll be doing this again once the moon goes away in a week or two, and we'll definitely go galaxy hunting because we can see a lot more, and it'll also be cooler. David wanted to go to M8182, which is the Bodhi and Cigar Galaxy. The exploding Cigar Galaxy is one of my favorites. Very cool. It's a twin galaxy. They're way down here, so they're a little bit too low. I like that they're far away from the moon, but we just can't get them. Sorry. And yeah, that's would be nice, but can't do that. Let's look at the ET cluster. This is a very entertaining star cluster. Great to show kids in a telescope because it does look like ET. And what's fun about it also is we can just do a 20-second exposure and we can get a good picture. This is it's just 100 stars in a cluster. It's easy to see, easy to find. Some people think it looks like an owl with 2 eyes. So it's the 2 eyes that are distinctive. It's called NGC 457. And it's in Cassiopeia. That's the queen on her throne. There we go. So you got to tilt your head to the right. Let's zoom out a little bit. There. So this would be E.T.'s eyes, and then like this is his feet, legs, little feet down there. His body's right here. Or it's an owl sitting there with the 2 eyes. Same thing. But E.T. cluster is very beautiful, and it's just fun at star parties to show people and ask them, "Can you see the 2 eyes? Do you see the owl?" And they'll always say yes, even if they don't believe you.
Pac-Man.
The Pac-Man. Pac-Man. What number's that? I don't think. Oh yeah, Pac-Man is close by. Yeah, I got a picture of that recently. Pac-Man. I'm gonna need an NGC for that one. Or I can pull a browser up. it's a race now. $281. Okay. And again, this is one of the red stellar nursery. Really close. We got lucky on that one. So we'll go up to 30 seconds. But on a night like tonight, I can get a good picture of the ET cluster. Okay, I would just take maybe 2 hours worth of 5-minute exposures just like this, and then stack those, and you can get a very nice picture. I don't think I've ever gotten a picture of the ET. I mean, well, I don't know if if you take a look at my Instagram, I probably have 800 things I put up or 1,000 posts by now. So I sometimes lose track because I've been doing this, you know, remotely stuff for almost 7 years now. Okay. Waka 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 waka. I think there's the mouth. The mouth is right there. Yeah, the mouth is up. It's chomping up to the left, so it's circular up to the left. I'm seeing a nice little cluster here. That's probably born out of the gas recently. But yep, that's the ET cluster. I'm sorry, Pac-Man. But that's not one that's easy to see in the telescope. I don't think I've ever seen Pac-Man with a telescope. I mean, it's possible. This field of view here is really similar to a low-power eyepiece in a medium-sized telescope. So that's a perfect eyepiece to see this object. But I've never done it. Any other? Let me take a look at the chart. What do we got here? Mars is coming up. If we click on Mars, it'll tell us how high up it is. 17 degrees. The roof there on the east side is probably 25 degrees. So it doesn't look like we'll be able to hit that tonight. Oh, what's this? Neptune. Let's go to Neptune. That's the furthest out planet, officially. Let's look at tiny Neptune on video. Yes, there we go. I'm going to zoom in. 5x. 10x, and you can see that it does have a little bit of a bluish tinge to it, but that's the planet Neptune, which is probably, the light took 3 or 5 hours to get here. 10 hours? That's pretty far away. So that's Neptune. I don't like to leave it on video for too long because it really heats up the sensor. Wow, we are getting blown around.
Pleiades, can you still get it?
The Pleiades. Let's take a look at the Pleiades. Where is the Pleiades? Oh, they're right there. They have just risen. They are 1 degree above the horizon. Sorry, no Pleiades. What's this? I bet you this is Uranus. Yep, that's Uranus right there, and it has just come up. So when I do another session, we will get Mars and Uranus and the Pleiades. Those will all be great. And the California Nebula, that's a great stellar nursery, very red. So that's some of the things we can do as we get more into the fall sky, because a lot of the stuff we've been doing is more of the summer sky. And so we still have the summer sky with us out there in the desert this time of day. Well, I think that we're running out of steam here. We have taken a universe tour to take us from a satellite that is only 1 millisecond away from it. The light took 1 millisecond to get here, all the way to a lensed quasar that is 8 billion light years away. So that
Samer asks for the iris.
Samer asked for the iris. See, okay, all right. And I was butchering Samer's name last night until he put in the chat how to pronounce it. All right, this one's also in Cepheus. And what I like about this one is its beautiful blue color. It's another nebula. I think it's more of a reflection nebula. Okay, it's not going to have that excited hydrogen. It's going to be reflecting the gas from reflecting the light from stars nearby. I'll zoom in a bit. Good thing that the wind has calmed down. We're in the green zone here. Oh, yellow. As soon as I said that. But you can see that we can get pretty good pictures even if it's yellow. Even if we're getting blown around, we're getting pretty good shots here. Yeah, there's the iris. It is. See, you can see that there's a cloud of gas that prevents us from seeing the stars nearby. I'll go out, and then we'll go in. This star here, I think, was recently born, and it's got all these clouds swirling around it, and it illuminates these clouds. And I think this is also fascinating because month to month or year to year, it changes in its appearance. So that is different, yeah. And I think what's weird also is it's kind of squarish. See, it's a square structure. So that's the iris. I have some good pictures I've taken of that, and this one takes 3 hours to get a good image on the iris. All right, I'm going to sign off here. I want to thank everybody for sticking with me till almost midnight. It's been tons of fun. We had great chat there. We can't see the... Okay, all right. One more. We've got the Pelican. We're going to do the North American first. Yeah, we got to do this. This is a beautiful, again, a nebula, the North American, and it actually looks like North America, and right next door is the Pelican, and it looks like a pelican. But we've centered on North America first, then we'll do the Pelican second. Now, with such a short exposure, we're not going to see North America, but we are going to see Mexico. Okay, so be prepared to see Mexico. Right by Deneb, right there. What the heck are we looking at here? I think Mexico's at the top. I think Florida's up there. Now what if we flip this thing around? Flip it around. There. That's North America. Mexico's here. All of North America. This is North America. There's the Gulf of Mexico. Dark right there. Gulf of Mexico. Mexico's right there. Florida is hard to see, but right there. So, but the good part of Mexico we're not seeing. So, let me see if... What's this right here? Is 6997? I think that's the Pelican. Let's go over to the Pelican. The Pelican fits in the field of view. That's the good thing about that. Let's go to 45-second exposure. And I've got a really good shot of the Pelican. that I took a couple of years ago, and you could really see that, what it is. Especially its snout. You can really see the snout of it, this big, well, okay, beak. There. Now, that's cool. Yep. So you can see the eye and its pointed head and its beak. And yep. So that's a pelican, and that's about 4 hours worth of exposure. So we're taking a picture of that. So that's a finished one, and now we're going to see a unfinished partial picture. Okay, I don't see anything. I don't know what we're pointing at. Yeah, this is tough. Tough, tough, tough night with that moon. The moon is conspiring against us. What makes it tough is it's so big and it's so faint. You got to have it perfectly aimed in order to get a shot. And a night like tonight, that's a tall order. So, well, we gave it a shot. But thanks for everybody for coming. I want to tell everybody to take the survey. I wrote the customer satisfaction survey for Astronomy at the Beach. And if you go to the website, the main website for GLAC and Astronomy at the Beach, upper right-hand corner, it says take the survey. I urge everybody to take the survey. Be honest. Tell us what you liked. Tell us what you didn't like. And we might do some online stuff next year, even if we're back to normal and doing telescopes out on the beach. So we do want to take your input and use it. So thank you everyone for participating. I'm going to sign off. I'm going to leave a slideshow on. It shows my Instagram. So if anybody's interested, you can take a look at my Instagram. I try to post things every couple days. So thank you everyone, and keep following me. I might be doing this again once the moon is out of the way. Good night.